Okay, here is a review and potentially an extension of the idea of distribution in mathematics. So if we want to multiply 7 times the quantity of x plus 7, most students like to draw these lines here to show distribution. What's happening is we are, in some sense, sharing this 7 with both the x and with the other 7, because the 7 is being multiplied with this entire quantity, x and 7. So 7 times x is 7x. And then 7 times positive 7 is positive 49. Okay. So we just distributed 7 with the quantity x plus 7. What about with variables? We have, in the second problem, x times the quantity 3 plus x. Well, x times 3 is 3x. But then, and I'll just kind of make a note at the bottom of this, the second distribution is x times x. It's not 2x. Well, remember that when we multiply the same number twice, so something times itself, by definition, that is x squared. All right, it's a bad square. Okay, so we actually have plus x squared here. Moving right along. Next, we have negative 2 times x, which is negative 2x. And then to remind us of our sign properties, negative 2 times negative 8, that's a negative times a negative, that will give us a positive 16. Okay? And finally, we have x cubed. Let me draw the lines everybody likes in there, just for the visual. So we have our first multiplication is x cubed times x squared. Does that equal x to the 6th power? Do we multiply the 3 and the 2? Well, let's be a little more formal with this. We have x cubed, so we have 3 x's. And then we have 2 more x's from the x squared. So this actually is not x to the 6th. This is only 5 of those x's. So overall, we have x to the 5th power. Okay, so x cubed times x squared, we actually add those exponents. So we have x to the 5th power. And then the second multiplication is x cubed times normal x. So altogether we have 4 of those x's. But they're multiplied, so we don't say 4x. We symbolize that as x to the 4th power. So we put the exponent of 4 instead.